Using the ratio test, we're going to test 3e. So in the numerator, we're going to put our n plus 1 terms. So we have x to the power n plus 1 over 2 to the power n plus 1, and then square root of n plus 1. Okay, in the denominator, we end up with x to the power n, 2 to the power n, square root n. Okay, we're going to rearrange this and group some of these terms together. So we have the limit as n approaches infinity. Okay, in the numerator, I'm gonna start with my x to the power n. So I'm gonna end up with x to the power n plus 1. So that plus 1, I'm just gonna show as an extra x. And in the denominator, we have x to the power n. Those are gonna group together. I'm going to group together my 2 to the power n, so we end up with 2 to the power n in the numerator, and then the denominator we had 2 to the power n plus 1, so I'm going to show that plus 1 as a times 2. That's going to be grouped together. And then lastly, we have our n terms, so this works out to be square root n over square root n plus 1, and again, that's going to be grouped together. Okay, so some things are going to cancel out here, so we have some simplifications, and we're going to be left with, after that simplification, we're going to be left with limit as n approaches infinity in the numerator, and I'm going to keep this grouped together, root n over root n plus 1. Okay, so that's going to be kept together. The rest of that just is going to end up being x over 2. And this needs to be less than 1. Okay, so as I apply the limit to n, the blue term becomes 0. So I end up with 1 times x over 2 must be less than 1. I'm going to multiply by 2 and get rid of the absolute value. So the right edge of this, I'm going to have x is less than 2. And on the other edge, when I take away the absolute value, I'm going to end up with negative 2 is less than x. Okay, so the center is going to be at 0. And our radius, looks like we can see our radius there is going to be equal to 2. So I'm going to say my radius equals 2. Okay, I can just take that term here. I can just take this term here. That's my right edge. X must be less than 2. And my left edge is x is greater than negative 2. Okay, so there's my right edge and left edge. Now at this point I have my radius and my center. I'm going to test my endpoints to see if it converges at the endpoint. So I'm going to test x equals 2. To test x equals 2, I just plug that x into the original series from n equals 1 to infinity. And we're going to have 2 to the power n over 2 to the power n square root n. Okay, so this is just going to simplify to the 2 to the power n's cancel out. This is a p series where the p is less than 1. That means it's diverging. Okay, so this is an open endpoint, so it's not equal to that right edge. Okay, so my right edge is less than 2. I then test the left. So I'm going to plug in. So I'm going to test x equals -2. So I have -2 to the power n over 2 to the power n square root n. Now this will simplify almost the same. However, we're going to end up with -1 to the power n when we group the -2 and the +2 together. This makes this series alternate. And any converging series in any case, in a situation where an goes to 0 and it is alternating, those are all converging. So this is alternating, therefore converging. Okay, so it's alternating and an goes to 0. Maybe I should state that extra statement. Alternating and an goes to 0, therefore converging. So this is a closed endpoint. Okay, so what that means then is for the right edge then, I'm going to make it equal to. Okay, so maybe I'll just do it down here. So my interval that I had from my radius test, or sorry, my ratio test, my interval was less than 2 and greater than -2 because it is converging. Maybe I'll do this in a different color. Because this endpoint is converging, that is a closed endpoint, or we make it equal to. So our radius, our center is 0, our radius is 2, our interval looks like this. We can show it in the interval notation as well as -2 to 2. So this is a half open interval.